Hello there, chemistry students. Today we are talking about atomic numbers and isotopes. You probably have learned about isotopes in a previous chemistry class, but we're going to review them and then talk about how to assign some numbers to describe atoms. This is all basically from chapter 4.3 of your textbook. The first example of an isotope here is hydrogen. Sometimes we call one of its isotopes protium, another is deuterium, and a third is tritium, and they vary based on the number of neutrons that they have in the nucleus. And that's exactly what an isotope is. It's an atom, or atoms of the same element, that have different masses. And that's caused by having the same number of protons, because remember, protons determine the element, and a different number of neutrons, because neutrons and protons together are the heaviest parts of an atom. Electrons weigh virtually nothing. So having different numbers of neutrons changes their mass, which is going to affect how we detect them and how they act to some extent. Here's another example of a set of isotopes. We have lithium that weighs 6 because it has 3 protons and 3 neutrons, and still 3 electrons. They always have 3 electrons if they're isotopes, or the same number of electrons. Another isotope would have 4 neutrons, still 3 protons and 3 electrons, and then the third isotope of lithium has 5 neutrons and 3 protons and 3 electrons. Now, let's contrast this with another word that you may have heard of. So back to our hydrogen example. Hydrogen typically has 1 proton and 1 electron. An isotope of that would be deuterium, which has 1 proton and 1 neutron, and still 1 electron. It's different because it has an extra neutron, but the same because it has the same number of protons and electrons. On the other hand, if you change the number of electrons, you have an ion. H plus is a positive atom because it has 1 proton and no electron. It's still hydrogen because it has the proton, but it has a different number of electrons. Same thing with H minus. It's still got the 1 proton, but now it has an extra negative electron. We're going to use this to do some atomic math. There's a couple terms here you need to know, and the first is atomic number. This tells which element you have, which means that it's basically the same thing as the number of protons. And this is at the top of the box on the periodic table. And we've been using this to do our electron configurations because it also tells us the number of electrons, as long as you have a neutral atom, which is what we're going to work with primarily in this unit. The second thing you need to know about is the mass number, which is the weight or the mass of an individual atom. Each isotope has a different mass number, and that mass number is affected by the number of protons and the number of neutrons in the element, because remember, protons and neutrons are the heavy ones. This number will always be a whole number because it's always protons plus neutrons, and it is not listed on the periodic table. That number on the periodic table is an average of all the isotopes that exist, and we're going to be able to calculate that number from the periodic table based on how much of each isotope is present. We'll get to that in a minute. Let's first talk about how we'd represent the mass number and atomic number using some different symbols. Here, the X stands for the element that you're dealing with. We'll put the atomic number on bottom. Remember, that's the same as the number of protons. And then on the top to the left, we'll put the mass number, the number of protons and neutrons. This is a common format we use to show quickly which isotope we have. Another way to write an isotope is to write the whole element's name, followed by a dash, and then write its mass number, the sum of protons and neutrons. So either the symbol or the name are ways to represent the isotopes. Let's practice that. That's the best way to learn. So here we have 19 over 9F. Let's find the following information. How many protons does it have? Well, remember, protons and atomic number are the same thing, so it's got 9. Also, you could know that because it's fluorine, and if you look at your periodic table, fluorine's right over here, it's got 9 at the top. The number of neutrons, okay, let's come back to that one. Number of electrons, well, that's going to be the same as the number of protons. So that's also 9. And the atomic number is also 9. Those 3 numbers will always be the same. They may not appear on the list in this order, but those protons, electrons, and atomic number will always be the same. The number on top is the mass number, so we know that's 19. And we know the name of this would be fluorine because you've memorized those elements, right? fluorine-19 to show that it's the isotope that weighs 19. Now let's go back to the number of neutrons. Remember that the mass number is the sum of the protons and the neutrons. So if our mass number is 19 and we have 9 protons, how many neutrons do we have? Obviously we've got 10 neutrons. So we've got an extra neutron as compared to a balanced element. Okay, let's try it in table form. For this you're going to need your periodic table, so go ahead and bust that out. The first row here has calcium with a mass number of 40. So the first thing you want to do is find calcium on your periodic table. Calcium is over here. Its atomic number is 20. Remember, we can't look at the number on the bottom because that's an average of all the isotopes. So the atomic number is 20, which also means that's the number of protons and electrons. Then to find the neutrons, we do the mass number minus the protons, which turns out to be also 20 in this case. That conveniently worked out. Okay, our next one. In this case, we're only given the number of protons and neutrons. Well, we know protons and neutrons have to add up to the mass number. So 18 plus 22, hey, that turns out to be 40, same as in our last one. We also know that the number of protons equals the number of electrons, and the protons equals the atomic number. So that's 18 and 18. And now we can figure out which element we have. Oops, I forgot to look. The atomic number is 18, so we need to find 18 on our periodic table. That is Ar, argon. And hey, while we're doing this, let's write it as the isotope symbol. Here's where people often get confused. You forget what goes on top. Remember that the bigger number goes on top, so the mass number goes on top, and the atomic number goes on bottom. Okay, one more example of this. Here we're only given the mass and the number of electrons. Remember, electrons, protons, and atomic number are always the same, so we'll fill those in quickly. And then to get the neutrons, we'll do the mass minus the number of protons. So 80 minus 35 turns out to be 45. So it's got a lot of extra neutrons. And now let's identify which element we have. So the atomic number is 35, so we'll find 35, which is Br. So Br, and again, let's practice writing the isotope symbol. So we'll write the mass number on top and the atomic number on bottom. Excellent. Okay, we got one more example of that. Whoops, I'm getting ahead of myself here. If an element has an atomic number of 23 and a mass number of 51, find the following things. What I'd like you to do is try this on your own, bring it to class, and you'll check your answer at that time. Okay, we have one more concept we need to learn today, and that is average atomic mass. This is the number that's on the periodic table. So it's not the mass number. It's different than that. It's a weighted average of all the isotopes for an element. Well, weighted average? You've learned about that in math, but what does that mean? Here's an example. In this class, you calculate your overall semester grade based on a weighted average. Let's say this was your quarter 1, quarter 2, and exam score. You didn't really know what you're doing first quarter, so you got an 84%. Second quarter, you kicked it into gear, you got a 92%. And then you studied your butt off, and on the final exam, you got a 99%. Wow, that's incredible. Did you end up with an A? Well, what you have to take into account is that quarter 1 is worth 40% of your grade, quarter 2 is 40% of your grade, and the final exam is 20% of your grade. So to find your overall final grade, what you would do is take each of these percents, 40, 40, and 20, and turn them into decimal form by dividing them each by 100. Then what you would do is multiply the grade that you got for each quarter by that weight to figure out what portion of your overall score comes from that grade. So when you do that, you end up with 84 times 0.4, that's 33.6. This would turn out to be 36.8. And then this one would turn out to be 19.8. So the exam, even though it's awesome, doesn't count as much toward the total. Then you would add up those three numbers and end up with a whopping 90.2%. You got your A! Yes! Thank goodness for weighted averages. Well, here's how we're going to use it in chemistry contexts. This is kind of a way to write the formula. It's kind of a complicated way to write it. You can write that down if that helps you. Basically, the average is going to be the mass times the percent written as a decimal form Just add up all the percentages together. So here's another example. Let's find the average atomic mass of oxygen if its abundance in nature is the following. Okay, so 99.76% is oxygen 16. Let's convert that to a decimal by dividing by 100, moving the decimal place 2 to the left. So it'll be 0.9976. And that's the percent, and it weighs 16. The mass number is given to us. Now, we're going to see in a minute that the mass number is not always the exact mass, but if you're not told otherwise, just assume that the mass number is the mass of that isotope. Okay, so that's oxygen 16. Oxygen 17 is 0.04%, so move that decimal place 2. So, there's going to be 3 zeros on that one. That's a common mistake. People forget to move the decimal place the right number of spaces. And then finally, 0.2% is oxygen 18, so that'll be 0.0020 times 18. So multiply those out and add them up. Quickly, let's multiply that out. That'd be 15.9616.0068. So the oxygen 17 actually is very, very rare, so it doesn't contribute much to the overall mass, the average. Whoops. And then finally 0.036. So you can see that primarily 99.76% of it is oxygen 16. So when we add up our masses, hopefully our overall average atomic mass will be close to 16. So when you add those numbers up, what the calculator says is 16.00 something something something. But to 2 decimal places, it is exactly 16. And the units will be AMUs. So it's just like we predicted. Since most of it was oxygen 16, the overall atomic mass average will come out to about 16. Great, let's do one more of those. Magnesium has 3 isotopes. 79% is magnesium 24, which has an exact mass of 23.985 AMUs. So if you're given an exact mass, use that instead of just a generic mass number. 10% is magnesium 25 and has this exact mass, and the rest, what does that mean? We're going to have to do a subtraction, right? Because percents always have to add up to 100. And right now, 79 and 10%, that's only 89% of the total that's been accounted for. So 100 minus what we already know, 79 minus 10, well, that turns out to be 11. So the rest is 11% magnesium 26 with that exact mass. Okay, so what we're going to do to find the overall average atomic mass is to convert each of our percents to decimal, so 0.79, 0.1, and 0.11. Then we'll multiply the percent by the mass and add them up. These really aren't too difficult once you get the hang of it. It's really just kind of paying attention to detail and making sure you move your decimal place the right number of spots. And it's really easy to check your work in most cases because if you're given real numbers that have been empirically studied by scientists collecting data about all magnesium atoms throughout the years, the numbers that you get should add up to the number that's on the periodic table. So multiply those out, add them up, and you should get 24.30 AMUs, atomic mass units. Now, I didn't check this ahead of time. Let's see if that's what the periodic table says for magnesium. Let's see if we're working with good data. 24.30 for magnesium. Hey, 24.305. That's pretty darn close. So I'd say we got some good data there that we were working with. Okay, folks, that is it for today, but I have one final joke for you. You ready? 2 atoms are walking down the street. There they are. They're 2 hydrogen atoms. One says to the other, "Hey, hold on a second. I think I lost an electron." And the other one says, "Are you sure?" The original one says, "I'm positive." Get it? Positive, lost an electron, which is negative. Now it's just positive. Ha ha ha. It's a good one, isn't it? Okay, folks, I hope you enjoyed that. Hope it was helpful. Come to class with your questions, and we will practice it then.